Hello all. So I am starting a new series on inorganic chemistry, the book Housecroft. So we will do the practice questions like worked examples and self-study exercises. So I will start from chapter 1. I will do some examples from the this chapter. So comes to the first question, that is the worked example on relative atomic mass. It says that the calculate the value of relative atomic mass for naturally occurring chlorine if the distribution of isotopes is 75.77% for 35 chlorine, 24.23% for 37 chlorine, and accurate mass for 35 and 37 chlorine are given. This will be given in all the questions, most probably in NET exams and the GATE exam they will give you. So the relative atomic mass of chlorine is the average of natural abundance and the accurate masses of both isotopes. So the relative atomic mass is equals to the natural abundance of 35 chlorine and the accurate mass of 35 chlorine, and it is added with the natural abundance of 37 chlorine and the accurate masses of 37 chlorine, and when you calculate it, it will come around this. So this is for the worked example. Now comes to the second, the self study exercises. So the first question is, if relative atomic mass for chlorine is 35.45, what is the ratio of 35 chlorine and 37 chlorine present in a sample of chlorine atoms containing natural occurring chlorine? So you have been given the relative atomic mass. So you have been given relative atomic mass, and you will be given this accurate masses for both 35 chlorine and 37 chlorine in the exam. So to calculate the natural abundance and their ratio, the first thing you have to do, you assume that for 35 chlorine the natural abundance is x%, and for 37 chlorine the natural abundance is x minus x%. Now you add them, you calculate, and it will come around that 35 chlorine is 76% naturally occurring. Now you minus with the 100 minus x you do for 37 chlorine, and you will get that 25% is the natural abundance of 37 chlorine. Now the ratio of natural abundance uh, of these isotopes are 35 chlorine by 37 chlorine is equals to the 76 point by 24, and you will get the ratio of 3.17 ratio 1. Now comes to the second question, the calculate the value of relative atomic mass for naturally occurring copper if the distribution of isotope is 69.2% for 63 copper, 30.8% is for 65 copper. Accurate masses are given. This will be given most of the time. Now what is the relative atomic mass? You do same, natural abundance of 63 copper and accurate masses, you multiply them, then add with the other isotopes natural abundance and accurate masses, you will get the answer. Now comes to the next question, that says that why in question 2 is it adequate to write 63 copper rather than 63 copper to 9. Now you see, atomic number is equals to the number of protons. Now in a molecule, number of protons are not changing. If the molecule is same, the isotope is same, the atom is same, then the proton is not changing, right? Only the number of neutrons are changing. So number of neutrons are changing, that means the protons and neutrons make the mass of a atom, right? So the proton are constant, so atomic number describes the number of protons. So protons are not changing, that's why we will, what we will do, that we can represent it the isotopes stating atomic masses only. We don't need to write the atomic number because atomic number is constant, number of protons are constant, only neutrons are changing. So you will get that copper is on atomic number is 29, but the masses of isotopes are changing. So now comes to the fourth question, that says that calculate the relative atomic mass for naturally occurring magnesium, for 78.99% for 24 magnesium, 10% for 25 magnesium, and 11.01% for 26 magnesium. Now the accurate masses are 23.99 for the 24 magnesium, 24.99 for 25 magnesium, and 25.98 for 26 magnesium. Now you have to do the same thing. You have to just average the natural abundance of particular isotope and their accurate masses, and for other isotopes, and then for third isotope, and you add them and you will get the answer, the relative atomic mass, that is the average mass. So that's it for today. We will meet you in the next video, and I hope you will understand these concepts. Keep studying. Thank you.